1G. 1G was mobile networking in its prototype that escaped the lab era. Mobile phones didn't start as pocket computers. They started with one mission: make a voice call without a wire. And the hilarious part is, it barely worked. The first commercial 1G network launched in Japan in 1979 through NTT, and the US followed with AMPS in 1983. These systems were analog, meaning your voice was basically turned into raw radio and blasted through the air like a personal broadcast station. The result sounded like someone whispering through a fan while frying bacon in the background. This is also where the brick phone stereotype comes from. Early devices were heavy, expensive, and proudly inconvenient. The Motorola Dynatac-style phones cost thousands of dollars and delivered talk time that felt like a prank, around half an hour after a long charge. You weren't buying a phone. You were buying the ability to say, "Yes, I can take this call," while standing next to your car like you were in a futuristic movie, and you paid luxury money for it. Coverage was another comedy. In the city, you might get a usable signal. Step outside major areas and your mobile phone instantly became stationary because it didn't connect to anything. Security didn't exist either. There was no encryption, so anyone with a basic radio scanner and curiosity could listen in. Imagine negotiating a business deal while a random hobbyist is eating chips and enjoying the drama like it's a podcast. But here's the important part. 1G introduced the idea that made everything else possible: cells. Instead of one giant transmitter covering a whole city, the network was divided into smaller zones, each with its own tower. That allowed frequency reuse, which meant more simultaneous calls. That's still the core concept of modern mobile networks, just upgraded 1,000 times over. So yes, 1G was noisy, fragile, and wildly limited, but it proved that wireless calling could exist at all. And once people experienced making a call without being tethered to a wall, there was no going back. The only issue was that analog had hard ceilings, poor quality, limited capacity, awful security, and battery drain. You couldn't patch your way out of that, which is why the next generation didn't improve 1G, it replaced it. 2G. 2G was the glow-up. This is when mobile networks stopped being glorified radio experiments and started behaving like real communication systems. The big shift was simple but massive: analog to digital. The first GSM networks went live in 1991, and suddenly, voice calls didn't sound like you were speaking from inside a washing machine. Digital encoding cleaned up audio, improved reliability, and most importantly, made networks more efficient. More users could connect without the whole system collapsing into network busy suffering. But 2G's real legacy isn't voice, it's texting. SMS wasn't originally built to become a cultural phenomenon. It started as a practical feature for networks, short messages that could be handled easily for system communication. Then humans got involved and turned it into an obsession. By the late 90s, teenagers were texting under desks like secret agents, inventing an entire shorthand language to save time and money. LOL, BRB, TTYL, because every character mattered and thumbs could only move so fast. Parents saw phone bills filled with hundreds of messages and had a mini meltdown. Carriers saw those same bills and smiled like cartoon villains. This era also delivered iconic phones that became part of pop culture. Devices got smaller, tougher, and cheaper. Battery life became a flex. Some phones could run for days, which feels like mythology now. And the Nokia-style candy bar phone became legendary because it refused to die. You could drop it, throw it, practically use it as a hammer, and it still worked. And then there was Snake, the game that turned boredom into competition. Waiting rooms, bus rides, awkward pauses, Snake time. Data existed too, but it was slow enough to feel insulting. Early 2G data was tiny, and later upgrades like GPRS and Edge improved it, but you were still browsing mobile internet like it was being transmitted by smoke signals. UAP browsers gave you stripped-down pages that looked like a website's skeleton. You could check email, you could load headlines, you could maybe download a tiny image if you had patience and nothing going on in your life. Still, 2G made phones mainstream. It expanded coverage globally, made communication private through digital encryption, and introduced texting, an invention that arguably changed human behavior more than any network speed ever did. Once people got used to messaging and basic data, the next demand was inevitable: real internet everywhere. 3G. 3G is where phones stopped being phones that also do stuff and started becoming actual pocket computers. Commercial 3G networks began rolling out in the early 2000s, and the promise was straightforward: real mobile internet. Not the stripped-down text-only experience from 2G, but actual web access that looked like the web. Early 3G speeds weren't mind-blowing by today's standards, but compared to 2G, they felt like stepping into the future. And once upgrades like HSPA arrived, speeds jumped again, enough to make the internet feel usable instead of punishing. This is the era where everything modern begins. Browsing became normal. Email with attachments stopped being a nightmare. Map apps started working without forcing you into a rage spiral. And video became possible? Yes, it buffered, but it existed. You could watch clips on your phone and think, wait, why does this feel like magic? Video calling also started here, and early attempts were awkward, grainy, and full of people staring at themselves like they'd discovered mirrors for the first time. Then smartphones arrived and changed the stakes. When touchscreen phones and app ecosystems took off, 3G became the foundation. Apps only matter if they can connect. The rise of app stores turned phones into platforms, not just devices. Social media became mobile first. People didn't just go online, they stayed online, always. And that shift rewired daily life. Constant notifications, constant scrolling, constant just one more refresh. But 3G had real weaknesses. Coverage could be spotty outside major areas. Battery life took hits because phones were constantly pulling data, and constant data wasn't power-friendly. Networks also started getting congested as more people streamed, downloaded, and lived online. Upload speeds often lagged behind downloads, so posting photos could feel like a slow-motion tragedy. And as smartphone adoption exploded, 3G networks began to buckle under demand they weren't built for. They were designed for some people sometimes, not everyone all the time. Still, 3G was the turning point. It made mobile internet a habit, and once the world got addicted to being connected everywhere, the next demand became obvious: faster speeds, lower delay, and enough capacity to handle everyone streaming simultaneously. That pressure is what created 4G. 4G LTE. 4G LTE is when mobile internet stopped being pretty good and became essential infrastructure. Early 4G networks launched around 2009, and the jump wasn't just speed, it was architecture. 4G moved to an all-IP system, meaning everything became data packets. Browsing, streaming, messaging, and eventually voice calls too. It's the moment your phone became a portable internet terminal that also happens to make calls when it feels like it. Speeds climbed into ranges that made HD video practical, and that single change had huge consequences. Buffering stopped being a constant. Music streaming became normal. Video calls stopped feeling like a glitchy science project. And social media didn't just grow, it exploded. The scroll forever era is basically a 4G invention. Apps like ride-sharing and delivery services became instant because the network could respond quickly enough. Latency dropped compared to 3G, which meant interaction felt smoother and more real-time. The hardware evolution matched it. Phones got bigger screens, better cameras, more processing power. Suddenly, your phone wasn't just how you talked, it was how you navigated, watched, paid, worked, and documented your life. 4G hotspots became legitimately useful. For some people, 4G was faster than their home broadband, which is impressive, and also kind of embarrassing for home internet providers. But 4G still has limits. Crowded environments, stadiums, airports, concerts can still collapse performance because everyone is uploading and streaming at once. Capacity becomes the enemy. And while 4G latency is solid, it isn't instant. Certain applications need ultra-fast reaction times, and 4G can't reliably deliver that at scale. Add in the explosion of connected devices, watches, sensors, cars, smart home systems, and you start seeing why 4G began hitting ceilings. So 4G became the backbone of modern life, but it also created the next problem. The world started connecting everything, not just phones. Networks needed to handle more devices, more data, and lower delay simultaneously. That's the setup for 5G. 5G. 5G gets advertised like it's simply 4G but faster, but the actual story is density and responsiveness. Commercial rollout began around 2019, and depending on spectrum, speeds range from nice upgrade to how is this wireless? But speed isn't the only target. The bigger goal is lower latency and massive device capacity, because the future isn't just phones. It's everything connected at once. Here's why 5G feels inconsistent. It isn't one experience. Low-band 5G covers wide areas and penetrates buildings better, but often doesn't feel dramatically faster than strong 4G. Mid-band is the sweet spot. Better speeds, decent range, practical coverage. And mmWave is the flashy version. Extremely fast, extremely fragile. Walls block it, trees block it. Sometimes your body blocks it. It's like having a supercar that only works on one perfect road in one perfect neighborhood. 5G also introduces advanced ideas like slicing, virtual lanes inside one network where different services can get different performance guarantees. That matters for things like industrial automation, large-scale IoT, and critical communications where reliability is more important than raw speed. In theory, 5G enables smarter infrastructure, real-time traffic systems, connected sensors, more responsive logistics, and coordination at scale. But there's a reality check. mmWave needs dense towers because its range is short, and that's expensive. Indoor coverage can be weaker depending on deployment. Early devices struggled with power efficiency, and marketing didn't help. Many places labeled as 5G were basically upgraded 4G, so users saw the icon and felt nothing. That's why 5G has a reputation problem. The tech is real, but rollout is gradual, and the most dramatic benefits often show up in specific areas or specialized use cases, not in your everyday scrolling. So 5G is impressive and foundational, but it's still maturing. And while it's being built out tower by tower, researchers are already pushing toward the next leap: 6G. 6G. 6G isn't something you can buy, subscribe to, or turn on in settings. Right now, it lives in research labs, prototypes, and planning documents. Standards bodies are still shaping what 6G should be, and most expectations put early deployments in the early 2030s. Translation: exciting ideas, slow timelines. So what's the goal? Push performance into extremes while making networks smarter and more integrated. Researchers explore higher frequency bands like terahertz, which can carry massive data but struggle with range and obstacles. There's also a huge emphasis on AI-native networking, networks that can monitor conditions and optimize themselves in real time, predicting congestion before users feel it. Another major theme is integrating communication with sensing, so the network doesn't just transmit data. It can help measure environments, track motion, and deliver extremely precise location services. Then you get the futuristic concepts: advanced immersive telepresence, more realistic 3D communication, and networks blending ground towers with satellites and aerial platforms for broader coverage. Some of these ideas may show up first in industrial or enterprise settings long before consumers notice anything. That's usually how these shifts happen. Consumers don't need insane peak speeds to watch videos. Industries need reliability, low delay, and massive coordination. And cost will be the big fight. Higher frequencies demand new infrastructure. New infrastructure demands huge investment, and investment only happens when there's a strong reason to pay for it. That's why it's important to treat 6G claims correctly. When you hear extreme speed or latency numbers, you're usually hearing research targets. Targets are not guarantees. They're goals that help guide engineering, funding, and development. So 6G is real as a direction, but it isn't real as a finished product. It's still becoming defined, which is exactly why talking about 7G as if it's a scheduled sequel is jumping ahead too far. 7G. If you're wondering about 7G, you're doing what humans always do, skipping to the last page to see what happens. But here's the honest version. 7G isn't a defined standard or roadmap right now. There's no official timeline, no clear requirements, and no real standardization momentum like you see with 5G and emerging 6G. Most 7G talk today is speculation, hype, or future branding. And that's not a problem, it's exactly what you'd expect. Because mobile generations don't appear just because the industry wants a bigger number. They appear because the current generation hits a wall, a real wall, a this won't scale wall. 1G hit walls on quality and privacy. 2G hit walls on data. 3G hit walls when smartphones and streaming overloaded it. 4G hit walls as the world started connecting everything and demanding lower delay. 5G is designed to handle density and responsiveness at scale, and 6G is still being shaped to push the next frontier. So what would trigger 7G? That's the missing piece. We don't know what the post-6G crisis looks like because 6G isn't even deployed yet. The wall could be energy efficiency. Networks and devices might need huge power improvements to scale globally. It could be spectrum limits, where we run out of practical bands that can be deployed economically. It could be infrastructure cost, where building denser networks becomes too expensive for the benefit. Or it could be something new entirely, like needing seamless integration of terrestrial, satellite, and aerial systems as one network everywhere on Earth. So when you see 7G leaks promising insane speeds and launch dates, treat it like sci-fi. Fun to imagine, not something you can plan around. The credible way to include 7G in a video is simple. It's a placeholder for the next big problem, and we won't know what that problem is until 6G arrives, and then eventually runs into its own limits. So that's the full evolution. 1G proved wireless calls were possible, 2G made phones personal with texting, 3G brought real internet, 4G made streaming normal, 5G tries to make the network fast and crowded-proof, and 6G is the research world's attempt to push it into the next decade. And about 7G, no, it's not coming soon. It doesn't exist as a standard because the problem it needs to solve doesn't exist yet. Generations don't show up because marketing wants a bigger number. They show up because the last one breaks. So tell me, what was your first real smartphone network, 3G or 4G? And if you want me to do a full breakdown on Wi-Fi generations next, Wi-Fi 4 to Wi-Fi 7, comment Wi-Fi and I'll do it.